integral 0 to 1 ln x dx. Why is this improper? Well, log is not defined at 0. There's asymptote there. That's why it's improper. Okay. So the easiest way to determine the convergence of this is probably just to directly evaluate, to be honest. Okay. How do we evaluate the integral of ln x dx? That's integration by parts. Okay, so I just directly wrote the answer here. I probably solved this before on my channel, so you can go check that out, or there's lots of videos or even websites to solve this very typical example. So you can look there if you need to see it worked out. Okay, but the integral is x ln x minus x plus c, the indefinite integral. Okay, so we're going to use this antiderivative to help us out to evaluate the improper integral. Okay, we're going to write it as a limit first, limit as t approaches 0 from the right of integral from t to 1 ln x dx. Okay, so when we do fundamental theorem of calculus, when we integrate and do fundamental theorem of calculus, we use the antiderivative, right? So that's when we use that, we give it a plus c because it's now a definite integral. Okay, so x ln x minus x, evaluate from t to 1. Okay, so we plug in the upper bound first, ln 1 is 0, so we get 0 minus 1, and then plug in t over here, okay? So this is just a constant. We can move it outside the limit, or when we take the limit of a constant, it's just a constant, I should say. So that's what happened there. And then we need to take this limit as t approaches 0 from the right of t ln t. We need to use L'Hopital's rule here. Don't forget that. So in order to use L'Hopital's rule, we need to have it as 0 over 0 or infinity over infinity. Right now it's 0 times infinity. So we got to change it. Okay, so I rewrote it as ln t divided by 1 over t. So now it's infinity over infinity. Now I use L'Hopital's rule. Derivative at the top is just 1 over t. Derivative at the bottom is just minus 1 over t squared. Okay, simplify. You should get, you can pull this minus sign out. So it becomes a plus. And then just t squared, we move on top. So t squared divided by t is t. Okay, limit as t approaches 0 t, that's just 0. So it's the final limit is -1. And therefore, the integral converges and it converges to -1. So I think this is the simplest way to solve this one instead of doing a comparison test. Okay, so I would just evaluate it. It's not too bad. All right. Hopefully this was helpful. Please check out the next video if you're interested. And please give this video a like if this was helpful for you.